let's talk about factoring by grouping. This is yet another kind of tool that helps you factor some expressions. It doesn't always work, but it's just another tool that you can have at the ready for when it does work. So if you'll notice, this has 4 terms, 1, 2, 3, 4, okay? So it's not my typical trinomial, it's a cubic. So I'm trying to look and think about how I could break this up into its factors. Now I could certainly just dive in and try to kind of do reverse double distribution and see if that works, and kind of do some guessing and checking for what would multiply to equal the first term, guess and check what would multiply to equal the last term, and see if that would combine to give me that. And you probably would be successful. In fact, I bet you could figure that out. If you want, you can pause the video and try that. Just reverse double distribution. But algebra exists to give us tools to make things easier, and that is a little tricky. So factoring by grouping is a strategy that helps us make factoring like this a little easier, and we do exactly what it suggests by the name. We group terms together. So for example, I'm just going to group those first 2 together and those second 2 terms together. Okay? I think you agree adding those parentheses didn't change anything, right? Associative property, I can associate different terms together without changing anything. Okay? So now, I'm just going to look at these first 2 and factor out a greatest common factor. I'm going to see what's common to both of those. Let's see, 6 and 16, I can factor out a 2. They both have an x squared, so that's going to be my greatest common factor. This leaves me with a 3 and an x. Again, I'm just undoing distribution. You can always check by multiplying those together. This would give me a 6x cubed. Yep, I did that correctly. My subtraction, 16x squared divided by 2x squared, that leaves me with an 8. All right, plus. Let's do the same process here. I have 2 terms. What do they have in common? Well, I can go through my multiplication tables and say, oh, I think they have a 7 in common. 21x divided by 7 leaves me with 3x. 56 divided by 7 leaves me with an 8. Oh, do you see what I see? Oh my goodness! I hope you see what I see. I took 4 terms. I now have 2 terms. 2 terms. What do those 2 terms have in common? They have 3x minus 8 in common. That 3x minus 8 is a greatest common factor. I can factor that greatest common factor out from those 2 terms. What do I have left over in this first term? I have a 2x squared left, plus. What do I have left in this second term after I divide out a 3x minus 8? I have a 7. Ta-da! I turned 4 terms into 2 terms, and I turned 2 terms into 1 term. Now I just want to look at each factor and make sure it's prime, make sure it can't be factored. I'm thinking I'm done. This would be a fully factored version of this. Make sense? Now, if I just double distributed, I'd get 6x squared, 6x cubed, 3x times 7, 21x, negative 8 times 2x squared, negative 16x squared, negative 8 times 7, negative 56. It works. It works. So that was a strategy, factoring by grouping, that is very handy. Let's try one more. And again, this won't always work, and sometimes you have to rearrange, you have to change the order so that the grouping works, and sometimes factoring by grouping doesn't work, so you have to use another strategy. Let's try this one right here. 2x cubed plus 5x squared minus 18x minus 45. I had to write this one down because only certain ones work with factoring by grouping. Okay, again, I don't always have to group the first two together. I could rearrange this and try different groupings, but let's just see if it works. I'm just going to go ahead and do that. But, ooh, I can't just put parentheses around this with that subtraction there, because then that would change things. Whenever you have a subtraction in front of a parentheses, that means you're distributing it in. So instead, is it okay just for me to write a subtraction as plus a negative? That's fine, right? Subtracting a number is the same as adding a negative. So I'm going to do that first, then I'll put in my parentheses. Are we okay? All right, factor by grouping, look for a greatest common factor. I'm thinking an x squared is common to both of those, leaving me with 2x plus 5. Plus, greatest common factor, I'm thinking a 9. And I'm not just going to take out a 9, I'm going to take out a negative 9 because I have an I on what I want left over. If I take out a negative 9, that's going to leave me with a positive 2x and a positive 5, and that leaves me with something handy. Your goal is always to get a common factor. 2x plus 5 is common. I've got two terms. Voila, they have a common factor. I'm going to factor out a GCF, 2x plus 5. First term, I have an x squared left over, plus a negative 9. Can I just write minus 9? I have that negative 9 left over in the second term. And let's do what we did last time. This is factored, it's one term, but let's make sure it's completely factored. That factor looks prime. I think I'm done. Ooh, difference of perfect squares. I can keep factoring that. So 2x plus 5 is going to be multiplied by x minus 3 times x plus 3. That would be a fully factored version of that first expression. Try it. This is fun, factoring by grouping.